Okay, so the volume of a sphere has the following formula, and I'll explain what this diagram means. The volume is 4 over 3 pi r cubed, okay, pi r cubed. So it turns out if you do an experiment with a cylinder, okay, with a cylinder that fits, okay, as a height exactly the diameter of a sphere. So let's say you have a cylinder with water in it, and you put this in here, okay, and whatever the water comes out, so we can have another jug on below it like this, right? So water will spill out onto this one at the bottom, and then you can pour that into a measuring cup to see how much of the original came out. That will tell you the volume of the sphere. So it turns out the volume of the sphere, if you do this experiment, is exactly 2/3 of this cylinder. Okay, so that's 2/3 of cylinder is pi r squared times h. But in this case, h is equal to 2r. So 2 times 2 is 4 over 3 pi r cubed. Okay, that's where the formula comes from. And we can actually mathematically prove this more precisely rather than using this experiment using calculus. Okay, but of course that's beyond the scope of this grade level math. So at this point, just understand that intuitively this formula makes sense, and we want to just use this. Okay, so example 1. So let's say you have a cube, and the edges of the cube is exactly 10 centimeters, and we have a sphere that fits perfectly tightly in this cube. What is the volume of this cube? Okay, let's think about that, right? What is the volume of this cube? So the key thing is, from top to bottom of the sphere, that length will be exactly that. So the diameter is equal to 10, making the radius of the sphere being 5 centimeters. With that, we can find the volume. Pi 5 cubed. Okay, so that gives you, if you punch in the calculator, you get 524 centimeter cubed, okay? That's a sort of an indirect example, not super simple, but a little bit of application of an example of how to find the volume of a sphere.